Hello, this is Lucas from Wilger Industries. We're just going through Tip Wizard for a Pulse Width Modulation sprayer. So that's if you have a sprayer that has a system like capstan sharpshooter, capstan pinpoint, case aim command pro, aim command flex, aim command flex HD, or John Deere exact apply, or other systems like that. So simply enough, this is what you'll see in Tip Wizard. Start off with your application unit. We'll make sure to select Pulse Width Modulation and then search for spray tips. So click into there, we'll set our flow rate to what we'd like. So for an example, we'll use 10 gallons an acre. We'll put in our sprayer speed. Let's say we'll have 15 mile an hour max sprayer speed. We'll select our Pulse Width Modulation system. The reason for this, and this is something new or new as of late, if you click on it, you can actually bring up which pulse width system you have. So for an example, we'll say, hey, here's Raven Hawkeye. We'll use that, just because I didn't mention it earlier. We'll select our nozzle spacing and our nozzle or spray tip angle. So the reason for the pulse width modulation system to be selected by itself, some pulse width systems do have a different level of pressure drop through their solenoids and through the systems. So it has become necessary to actually pull in their relative factors of pressure drop into Tip Wizard, so you get the most accurate results possible. So we selected 110 degree spray tips. So pretty much everything up till now you've known. I've said it before, and usually guys kind of get lost at the target droplet size. So we're a little bit different at Wilger. We intend you to use the droplet size information to be able to make better selection. But with that comes a little education as far as what the droplet size is that you're targeting, because it's less commonly known. Some chemical labels are coming out with that information listed within it, which is great. But for the time being, typically what you'll end up seeing is something like this. You'll see in application information as it pertains to nozzles and pressure, you will see an ASABE, which is the Association of Agricultural Bioengineers, and that's the standard, or the organization set the standard as to what a coarse droplet size would be. So the nozzles themselves, you'll see that coarse listed in charts, readily available, but the droplet size can differ a little bit because you get a little bit more customization you can put into it. Here's an estimated VMD range, or droplet size range. Again, it doesn't necessarily mean a droplet size that's going to be smaller than 340 microns. It can't be a coarse one, because it can. It's just an estimate. So simply enough, your chemical label will give you this, to which you can kind of confer to the chart. Simply enough, for our example application, let's say we're using glyphosate as a pre-burn application, so pre-plant application. For the most part, you might expect something around a relative droplet size range for glyphosate, around 350 to 450 microns. So what that means is the smaller droplet size, you're going to get finer coverage or finer spray, but you're going to be getting a lot more drift as well. So typically that would be reserved for ideal conditions. Ideal conditions where wind is in your favor, there's nothing susceptible nearby, or you've slowed down a little bit so you can afford yourself a little bit finer spray. That's what the smaller droplet size in that range would be tailored to. So right in the middle would be something like 400 microns. So that might be more suitable to what your realistic or your typical conditions would be. Less than ideal, but not bad. And then on the top end, so the bigger droplet size, where you might be looking for like a 450 droplet or 450 micron droplet size, that might be more in those drift sensitive areas. Or if that's all of your farm where you're drift sensitive, or you have a lot of urban spraying or conditions in the environment, be it wind or otherwise, that limit the amount of drift you can tolerate. But as a ballpark, 400 microns is a pretty good place to be for most applicators, so we'll use that as an example. Make sure to read the little disclaimer here. Again, with the droplet size information, it's basically for comparison relative to our other spray tip series, just to be able to pick the best tip for you between those. But keep in mind, it is based on water and control conditions, so it is a good reference tool, but it won't be as realistic as you might hope in real conditions with wind and other factors or even active chemical ingredients and such. So I clicked search, and we've come to TipWizard results. So we have a few options here. TipWizard sorts based on the smallest tip first, not necessarily the best tip, because there's a lot of subjectivity to that. Up in the top here, there is a little light bulb icon. If you click that, you'll actually get a little legend, so it'll give you all the information or that's kind of in the charts, and gives you a little explanation of what it is and how it might affect your decision. So simply enough, we'll get right into it. I click the MR 11005, so the MR series, 110 degree angle and an 05 size. What we're going to see pretty darn quick though is the first three columns will designate our, the size or the relative flow of the tip, and within those three columns we'll see some trouble. You see some red pretty darn quick, and then the reason for that is that this tip at 40 psi or below, at our max speed at 15 mile an hour, is not able to put out the full rate that we need. So that's why the red is there. You can see that in the second or the third column here. That's your duty cycle, so the effective duty cycle or the on time. So what this is saying is over 100% duty cycle. To get your rate, you'd have to be over 100% duty cycle, which is not possible anyways. So to simplify the tip selection process, what I might suggest is that the first step being size up your spray tip. So to size it up, you're really looking at the first three columns. So your pressure, which is your pressure in the cap, your speed range, your minimum being your 25% duty cycle minimum, just in this range, and then max being 100% duty cycle. And then the duty cycle here just calculates, it does the math for you. So if we size up our spray tip, it simplifies a few things. First of all, we know right away this has failed the sizing test, because again, at 40 psi or below, we're not able to put on our full rate at the speeds we might be traveling, put it that way. So what we'll do, we'll go to the next size. So that was an 05, we'll go to the 06. This is the SR 11006, so a step finer than that MR, but with that, it's a bigger tip, so more flow, and typically everything will get a little bit coarser as we go into that there. So we'll look at the SR 11006, we'll size the tip up, so remembering with a pulse width system, in the pressure column here, this is your pressure in the cap. With the pulse width systems, as I referred to earlier, each solenoid has a different pressure drop through it. So there's a restriction through it that it's going to limit the pressure at the tip. So even though right here you'll see the pressure being 30 psi in the cap, for the larger tip series, if there's pressure drop or a significant pressure drop, the actual pressure at the tip will vary. It'll be lower than that, at the very least. The bigger the tip, the more that pressure drop influences the spray and such, but nonetheless, keep that in mind when we're considering what our lowest pressure should be. So sizing this option, this is the SR 11006. At 30 psi, we see that red stuff again, the red columns there, so we'd be able to spray from 3.6, which isn't really recommended. We just use that 25% duty cycle as a starting point in that reference range. But we'd be able to go up to 14.4 mile an hour, which is definitely nearing our max speed of 15 mile an hour. So even though our average speed may probably follow within that 14.4 mile an hour, which means our duty cycle will be a little bit lower, this might not be such a bad thing. The other thing, considering that our pressure being 30 psi, with that extra pressure drop through the system, we won't probably want to be operating any lower than 30 psi as well. So for this example, we'll still keep this as a good option, like for the tip sizing. So that first step is a menial pass. With tip sizing, consider it like you're sizing up the sprayer or sizing something up for the plumbing side of things. If the plumbing's too small, it's restrictive. So in this case, where the duty cycle is way too high, like over 100%, then it's restrictive. But if it's too large, what we end up doing is get inefficiencies that way. So if we skip to a much larger tip, just for example, so if we go to the ER 110-125, so double that size of tip. If you look at the duty cycle, so at 40 psi, our duty cycle is 52%. So when the nozzles are pulsing, they're off for near 50% of the time. So at our max speed, at 50% duty cycle, not the biggest deal. As soon as you start slowing down though, because again, 50 mile an hour we put in as our maximum. So if we're on average traveling 12 mile an hour, for an example, then our duty cycle is going to drop to the point where we're too large of a flow. Like that tip is too large for us. It's ineffective. If you're ever needing to check your duty cycle at any speed, for an example, if we're averaging 12 mile an hour, divide your travel speed into the max speed at that pressure. So 12 divided by 28.9, so 29 mile an hour. So that might be roughly around that 40% duty cycle. So with that, that's your effective duty cycle, your average speed. 40% is really the bare minimum. You never want to try go below that, especially at higher speeds, because what you can end up doing is have coverage misses or checkerboarding. Again, typically not an issue if your duty cycle's far beyond or higher than 40%, but nonetheless, that is something that you want to consider in that first step, that sizing of the tip, that your duty cycle is not too low. So we'll go back to that SR 11006. So where the droplet size is closest to what we're searching, so around that 400 microns, is at around 40 psi. So typically that's a pretty good place. Typically operators are more than happy operating there. 40 psi, we can travel up to 16.6 mile an hour, which is great. Again, given our maximum will be that 15. The thing to remember though, depending on your system, with pulse width systems that have a turn compensation factor built into it, is that even though you're never going to be hitting that 17 mile an hour chance is, that's your speed at your pressure, or at your center rack. So when that turn comp factor is built into it, as soon as you start deviating from straight, so as soon as you start swaying, let's say you're swaying around a slough or something like that, your speed range is on the outside wings of your sprayer are going to change a lot, or rather your actual speed on the outside wings of your sprayer is going to change. So that extra room on the duty cycle side of things, up to that 100%, is what you'd get as far as that flexibility into that turn. On the flip side, so literally on the other side of the sprayer, where your sprayer section or your other wing is slowing down more dramatically into like a straight corner turn, you might actually be going backwards. That duty cycle on the bottom end, or that reduction or that potential of reduction on your duty cycle, is that way to maintain your flow rate a little bit lower on the areas that you need it, so that you're not burning crop on the inside of that turn. So, but nonetheless, same goes if you're ever needing to calculate your duty cycle. Just travel or divide your travel speed at that pressure into the max speed at that pressure. So if we're traveling 12 divided by 16.6 mile an hour, then that'd be roughly that 80% duty cycle, which is great. So no issues here. As far as an ideal duty cycle, because it is a common question, again, just with considering that with our plumbing, we just want to make sure we're not ineffective. The plumbing side of things, the duty cycle is going to compensate every which way. Instead of relying or focusing on a tip due to its duty cycle, we want to make sure the duty cycle is okay, but concentrate more so on the application, the actual coverage and everything else, because that'll make a bigger difference than if our duty cycle is, let's say, from 60% or 80%, if that makes sense. So in this case, at 40 psi, where the droplet size is closest to what we were searching, we're at about a 90% duty cycle at our max speed, which is okay. There's no issues there. So we've satisfied our first step. And then now we'll go to the second step, which is looking at the application itself. So the droplet size, or the VMD, right around that 400 microns, which is what we targeted for glyphosate. Great. You have that ability to bump your pressure up to get your droplet size at the same speed, to get it finer for those typical or more ideal conditions. But also too, we would have that ability to drop our pressure a little bit to be able to reduce drift further as well. So, but at 40 psi, we'll follow the line across. So 393 microns. We're still in that coarse category, but you'll notice it changes right to that very coarse category. So it's pretty darn close. But nonetheless, we want that drift control, and it shows in this next column. So this next column is the percent less than 141 microns. So that's a percent of your flow that's made up of driftable fines. So if you go into the little light bulb, so that legend that we pulled up before, really good kind of tool if you do forget. So just a little reminder here, so it's a percent of volume which is likely to drift. Think of it this way, the small droplets, they only spray out of the spray tip and they can only travel so far, typically, you know, within that 3 to 6 inches. And at that point, they've near stopped. You know, there's no more velocity behind them. The only way they're coming down to target, or your crop or your weeds, is sprayer speed, wind speed, or gravity, to which gravity has very little control because there's very little weight or mass to those droplets. So yeah, for our purposes though, in a tip selection, we'll consider this written off. So this is chemical that we cannot control effectively, which is of risk to us, because again, we want to be able to minimize risk as we could. As far as this number, if this is the first time you've seen any relative level of drift, for a glyphosate application where it's a systemic application, where there is more drift sensitivity to it, usually within 10% is a pretty reasonable level of that drift control, or that drift factor. Again, that's in typical or more ideal conditions. In horrendous conditions, or conditions where you have more sensitivity, that's when you would target something much lower than that, maybe in the realm of that 6, 7, 5%, somewhere around there. Given at 40 psi, we're at 7%. We've satisfied our drift level, so we're pretty happy there. But on the other side of that balancing act, there's always coverage. So that's why we give you this next column here too. So that's a percent less than 600 microns. So the total flow of, or the percent of your total flow that's small. Anything smaller than 600 microns can be generally seen as effective spray. Anything bigger than that is too coarse. So effectively, it'll hit a leaf and roll off and do nothing for you, for your application, for, again, contact or systemic applications. Or it's just chewing up the water volume or the carrier volume, so you're just minimizing the amount of extra small droplets that would actually give you more coverage. So all in all, we want to try keep that as high as we can while keeping our drift as low as we can. Similar to that rule of thumb I gave you as far as maybe 10% being reasonable for drift control or drift level. For this percent of small droplets, or some refer to it as a coverage factor or coverage, we want to try keep our coverage factor above 80% to give us sufficient coverage for a systemic application like glyphosate. So 87% here, we've satisfied that. Cool. So what to do with this now? Again, we're selecting a spray tip, so we want to see the other options out there, but sometimes it could be overwhelming comparing one to the other. So to give you an idea of maybe kind of a shortcut that you can use to compare tips or discount other tips quickly, you can take that coverage factor, so 87%, and subtract the drift, because the drift isn't still included in that 87%. So 87 less 7%, so overall our effective spray volume is about 80%, which is pretty darn good. That's 80% of your chem, which is pretty much doing what it needs to be done. What we can do with that now is compared to another tip. So if we go to the next size, the SR11008, which is the same series of that gray one that we're looking at, that 06, but yes, a little bit bigger. So at 55 psi, that's where our droplet size is nearest to that 400 microns. We're around 8% drift, and less than 600 microns being around that 76%. So with that last column there, that percent less than 600 microns, that being your coverage factor, we tried to keep it above 80%. In this case, it is nominally lower, but when we do that same comparison as we did before, subtracting the coverage, so 76 less 8% drift, that 68% of our volume is pretty well effective for what we want to do it. So simply enough, if we're comparing tips and saying, hey, here's a tip that will give us 80% effective spray, compared to another one that a little higher pressure is going to give us 68%, that makes a much clearer decision which tip might be more suitable for us. Notably though, the SR11008 is a coarser spray tip, so we have more ability to drop our pressure and reduce our drift further at the cost of some coverage. But for most applicators, that SR11006 is a pretty good place to be, because again, you can still drop your pressure on the go with your Pulse Width system. So let's say we're applying at 30 psi, we're down to 5% drift. and our effective coverage is still 81%. So it still gives us, you know, above that 80% with minimal drift. So that might be our ideal tip. So in Tip Wizard, in the app itself, there's a little star here that's on every spray tip result, just as a favorite option. If you're looking on our website, something I would recommend you to do, so on the wilger.net website, there is in Tip Wizard another icon here. So that is actually going to be the print icon. So you click that and it'll actually customize a print chart for your application, for your farm, for your speeds, for your application. So literally it is what you're able to do with that tip. So we're not having to filter through tip charts. You get a more expanded tip chart. Everything's there for you. So it's a really good tool to reference to have in the cab to be able to keep working. So all right, I hope that helped you out.